Hello, and welcome to today's WJE webinar. My name is Liz Pimper, and I'll be your moderator. During the next hour, engineers Jason Aspin and Paul Gaudette will provide an overview of practical approaches to various issues related to the design of new plazas and the repair and restoration of existing ones. Topics will include plaza design, water management, temporary protection, surface preparation, expansion joint concepts, waterproofing testing, and finish options. This presentation is copyrighted by Wiss Janney Elster Associates. And now I will turn it over to Paul to get us started. Paul?
Thank you, Liz. Today's learning objectives are, by the end of the presentation, you'll be able to describe the various plaza components and their functions, explain how plazas manage water, including redirecting it, draining it, and preventing it from entering occupied spaces below, plan an existing plaza investigation and repair renovation, and identify laboratory tests that can be used for plaza finishes. Just a couple early items on history and types of plazas. We look at, there's usually two different types of plazas. One are on grade and some are on elevated structures. Today we'll be focusing more on elevated structures. But just a little bit of history of public places. Here are just two examples from 1667 at St. Peter's Square in DC from 1960. And by the way, he's the same person who built Baha'i House of Worship. Some other examples similar to what we'll be talking about today are elevated plazas, which really came to fore in the early 20th century and are constructed on structures, and this is what we'll be covering mostly today. There's some different examples. There's government plazas, such as the Federal Center. This is by Mies van der Rohe in Chicago from 1974. And then a much more complicated version of a plaza, which is the Barbican Center in London, England, from 1982, that has planters, water features, in entertainment venues. But let's first discuss plaza design. And what we want to cover with this is we'll kind of break it into different categories, and each one has a different level of aggressiveness to the repair or to the renovation. One is just repair. For instance, if you have some structural issues or concrete issues or leakage that you have to repair, then there's the more aggressive refresh and aesthetics that go along with it. You may want to replace it. You may want to change in use. In many cases, you're using a combination of these items. And oftentimes, if you're doing a more aggressive replacement, let's say, of the deck, you would certainly want to repair the structure and refresh the waterproofing. One thing we don't want to overlook are the sustainability goals for this type of work. I think by its nature, renovation is sustainability, but what are the goals in the design? And I think what we really want to shoot for is the decrease of the quantity of future repair work, and also to increase the duration between repair cycles. A repair is inevitable, but what we want to do is, once again, minimize future repairs and then increase the duration of materials, increase durability of repairs. And what that means is longer service life, protection systems for the plaza, which Jason will discuss later, and then monitoring along the way. And there's often selected items you can do to really try and extend the longevity of your plaza. So the first kind of overwhelming issue having to deal with the plaza is the number of components and elements that are there. And here's just a few of them. You have, let's say, ponding, poor drainage, you have lighting, you have planters. And really one of the more difficult items is the expansion joint that usually requires a little bit more care. Topping slabs, storefronts, column bases, all these different things on a plaza. And in many cases, you have a huge number of team members, depending on what you're going to do. The owner's situation can be somewhat complicated. The design can go from architects, landscape architects, structural, civil engineers, plumbing and electrical, lighting, and contractors. It can be an endless list. And what this means is it's complicated. There needs to be a lot of collaboration. There's phasing, and oftentimes the property's occupied, which certainly offers some levels of complication. So how do you plan for these repairs and renovations? In order to try and predict what you're going to get into and plan properly, usually you want to do a fairly thorough investigation. The repair design should take all these into account, and then the architectural design. And each one of these things in interplay with the other. The repair design will have to rely on the investigation for its data and how you're going to plan for it. Another item to look for is with the investigation is typically you want to look at what type of documents you have. In today's world, it seems like that's gotten much better with regards to digital documents, but you want to look at the original drawings, perform a condition survey, perform investigation openings, and definitely you want to water test so you can, if you're going to selectively repair, you're able to do that and find out where the damage is or where the leakage is coming from, and then perform laboratory studies. And really the investigation is the baseline for the quantities of the repair. Now, the investigation or condition survey usually survey the existing structure. The top surface is always the most challenging because you're really not looking at the structural component or the waterproofing in many cases. But you do want to determine how is the existing paving, whatever that material might be, is the wearing course. Identify areas of concern. Look for obvious problems, which could be leakage and other water-related issues. Trying to understand the vintage of repairs and also the what types of repairs have been done in the past. Look for gutters, crack injection, things of that nature. What's the existing drainage system? So some of the other exits in the paver wearing course, with a concrete wearing course, it could be deterioration. This happens to be an architectural concrete topping in the plaza, around the drain or along the joints. In this case, you've got cracked and displaced granite paving around a drainage system. One thing to note is it's not in the gray material, but only in the rose-colored paving, which indicates a difference. And that would have to be understood as why is it occurring in the larger granite, probably because of the big shapes, but that's something that needs to be understood. On the right is travertine stone, which oftentimes is something that's, at least in northern climates, is a little bit more sensitive to thermal conditions and strength issues. You would see it in more temperate climates. Some other issues, unit paving wearing course. This happens to have a herringbone layout, which is more dominant in higher use areas such as vehicle traffic. On the right is a unit paver system that's a running bond system. This is for pedestrian use only, with all kinds of efflorescence, dirt, water staining, and other conditions, which is an indicator of poor water management, which Jason will talk a little bit about later. Some other common conditions: failed sealant at the granite paver joints and wear course, and failed expansion joints at the failed expansion joint seal above the structural expansion joint in a plaza structure. And these are talked about earlier. So what conditions can these cause? Left unchecked, certainly drains can fail. They can become clogged. The flashing around the drainage system can fail. And these can lead to water leakage around the structural slab. And I'm not sure why that would occur, but that would be something that would be investigated. The next one would be cracking and deterioration of the concrete due to some reinforcing steel corrosion like you can see on this beam in the upper right, and then eventually more severe concrete deterioration, such as spalling and explosion of reinforcing steel that you can see on the lower right. Now, how do you understand this? What are your options to look at that? Let's say you've got 50,000 square feet of plaza to understand, and you're relying on inspection openings before you start tearing up areas of the plaza. And usually that's done through investigation openings. In this case, on the left, you can see it's exposed by removal of the granite paver. You can see the drainage mat material and the waterproofing down there also. On the right, you can see the precast paving system with the setting materials and waterproofing. This is a good example of looking at the waterproofing system itself in the drain. On the left, you can see ponding water, and you can see the flashing is easily pulled off the vertical area where the flashing was attached. On the right is a pedestal system, a little bit easier to expose the conditions. And in this one happens to be there's quite a bit of debris down at the surface of the drain, and you can see the drain itself. So with regards to plaza design, don't worry, I'm not going to read all these, but I did want to say, I'm just going to cover the top topics. What you can do here is later on, after we're done, it will be uploaded to the WJE website, so you can look at it. And if you want to take note of some of these things, but it's available that way. But the plaza repair design should really entail an engineering review. You want to make sure the loads of the proposed new design and even the existing structure are capable. You want to understand the as-built conditions. We always recommend some type of lab analysis on the materials to understand what is causing the deterioration. What are your problems, to make sure you're actually finding the cause and solving the problem. If there's structural repairs needed, those need to be understood, estimated, and how you would actually repair, because that will impact your architectural design. Review the drainage. Are there ponding areas on the top surface? Is resloping necessary? In some other conditions? And one thing I've learned over the years is one of the primary issues with plazas is the waterproofing system. Really, it's so important because a lot of funds can be spent on the top surface, but if you have leakage, that's a problem, and it's hard to get to once you've done the work. With laboratory analysis, there's all kinds of different things that can be done both with existing materials and new materials. This is just an example that's shown of ASTM C615, which lays out some minimums and maximums requirements for different materials. But for each type of material that you select, there are ASTMs that lay out some guidelines on performance criteria. So that's something you want to look at, both existing and new. And oftentimes if you're replacing it, certainly I think it's worth understanding this a little bit more before the material is ordered. And so what can you look for? Say if you're getting new stone, there are some engineering properties that are laid out, and usually the manufacturer will have done that and will have some record documents. One thing you do want to make sure is, are these up to date? Are they relevant? Is it for the portion of the quarry you're actually getting the stone from? And there's all kinds of different engineering properties and durability requirements that are listed. One thing you don't want to overlook is, and it's not very experimental or laboratory based, is prior use and experience. It's really nice to have seen a stone in service, in practice, in the same type of environment that you live in. And that's always a good test. Certainly something that works well in a more arid climate, hotter climate, may not work so well in a colder climate where you have more fluctuation of temperatures and rain. With concrete, for instance, if you're having a concrete wearing course or you're dealing with repair work, there's ASTMs laid out in different laboratory studies you can do, which are petrographic analysis, chloride content, which relates to the potential for corrosion of the reinforcing steel, carbonation and compressive strength. And once again, you can look these up later. I'm not going to go into these tests at this point. For new concrete, quality control is always important. And that has to do with usually your minimum tests are slump, air content, and compressive strength. There's many more tests that are done too, but these are usually the big ones that you're looking at. Once again, I'm just going to summarize these, but there's a lot of things that play into the architectural design. Is the wearing course selection. There's all kinds of different criteria that the design team would want to look at. Is it compatible? You want to make sure it's compatible with the setting system. So once again, you have to understand not just how it looks, but how it goes together. You want to specify and enforce quality assurance procedures on the site during the work. And what we always recommend is mock-ups. Mock-ups really give you a lot of information on appearance, the ability to install these, and also it verifies the level of craftsmanship of the people actually doing the work. The layout of the wearing course is important with regards to the waterproofing below and how that goes together. You certainly want the underneath the wearing course or on top of the wearing course, you want the system to work with the waterproofing, not against it. And I think you want to review the manufacturer's lab analysis of some of those stone materials like we talked about earlier. Some good resources for the wear course are the Tile Council of North America. Indiana Limestone has some good information on installation and materials. American Concrete Institute, of course, ICRI, or International Concrete Repair Institute, the BIA, the Brick Industry Association, and also if you're working with unit pavers and things like that, that's been absorbed into the Concrete Masonry and Hardscape Association, and that will help you with pavers. So I'm going to pass this off to Jason.
Thanks, Paul, and thanks everybody for joining us this afternoon. I'm going to talk a little bit about Plaza materials that we use often and their purpose, their function. I'm going to start with the bottom of the assembly and we're going to work our way up. We're going to focus on split slab systems today, where the waterproofing membrane is buried beneath the wearing course. A concealed membrane can sometimes be submerged in water, therefore it's got to withstand hydrostatic pressure. In contrast, water is meant to flow off of membranes on roofs, balconies, or parking decks. Some membranes intended for buried applications can be left exposed. Most membranes intended to be exposed should not be buried. They just can't resist the pressure. All right, starting at the slab and working our way up, a few thoughts on Plaza substrates from a waterproofing consultant's perspective. Cast-in-place concrete slabs are the best substrate for waterproofing because they're nearly continuous. When we place concrete on top of a metal deck, the deck significantly impairs the concrete's ability to dry downward, which will delay installation of the membrane while we wait for the concrete to dry. With precast structures, they've typically got a concrete topping slab to cover their connections and to cover the offsets between adjacent planks. The topping slab is prone to crack along these joints. More importantly, an item to keep an eye on, rotation of the precast concrete members at the support end can cause the end joints to open and close. And when we detail slab to wall transitions, we need to pay close attention to this type of movement. We might want to consider detailing some of these joints as if they're expansion joints. Now, there are a variety of waterproofing systems available that can work in split slab construction, including single ply membranes, self-adhering sheets, and both hot and cold applied liquid membranes. We're not going to cover the advantages and disadvantages of all these systems today. That'd be a separate talk entirely. What I will tell you is that I prefer liquid applied membranes because of their adhesion to the substrate, and that adhesion helps localize or contain leaks, which makes finding and repairing them in the future easier. That's a significant advantage for plazas because removing and reinstalling the wearing course or the overburden is expensive. The disadvantage of these adhered membranes is that they're vulnerable to moisture and concrete, and they're reliant on surface preparation. So those are the two items that I'd like to talk to you about this afternoon. Beginning with moisture and concrete. The roofing and waterproofing industry has been struggling with the issue of moisture and concrete, causing adhered membranes to debond. We've adopted some test methods from the flooring industry. Some manufacturers and trade associations have published threshold values for some of these tests. The issue is they're not consistent, and some of them aren't realistic. And the primary difference between the flooring industry and roofing or plazas is that the roofs and plazas are exposed and they're re-wetted every time it rains or snows. Currently, best practice to address this issue includes the following. Meet with the entire project team at the beginning of the project. Review the schedule, included the expecting drying times of each type of slab, considering the season when the slab will be placed. Also discuss measures that can be taken to minimize re-wetting and promote drying of the concrete. Avoid the use of lightweight structural concrete for plaza decks. The reason being, lightweight concrete aggregate is porous. It absorbs water. In fact, to prevent it from absorbing water when it's in the concrete mix, the lightweight aggregate is pre-wetted or soaked before it's added into the mix. The result is that you get concrete that has more water than it needs for hydration or the chemical reaction between the water and the cement. Just remember that lightweight structural concrete can take up to twice as long as normal weight concrete to dry to the point where we can adhere a membrane to it. One thing to consider at the beginning of the project is the use of a moisture mitigation coating. These coatings are intended to seal the surface of the concrete, trap the moisture inside, and reduce vapor drive out of it. Their intent is to allow us to install the adhered membrane and to allow the membrane to remain adhered over the life of the project. These coatings can be expensive, so it's best to consider using them at the beginning of the project. All right, on to surface preparation. Same thing, we're gonna start with basic and work our way to a little bit more advanced here. Once the concrete is placed, we need to cure it. And that means we need to maintain the temperature and moisture level of the concrete so that the chemical reaction between the cement and the water can take place and the concrete can develop its full strength. We cure concrete either by spraying it with water, placing wet burlap over it, or sealing the surface with a curing compound. If we're going to use a curing compound, it's either got to be approved ahead of time by the waterproofing membrane manufacturer who says their product will adhere to it, or we're going to have to remove it before we install the membrane. One way we can remove it is with a process called shot blasting. A shot blaster projects beads at high velocity to remove a material called latenance. Latenance is a weak material formed by sand, cement, and excess water from finishing the concrete that remains on the surface of both new and repair concrete. We recommend removing this to improve adhesion to the deck. This shot blaster is going to recycle the metal beads and it'll vacuum up the dust. We think it's best practice to shot blast again both new and repair concrete before adhering a membrane to it. One thing to keep in mind, a shot blaster will not remove thickened sections of membrane. You can see in the photo on the right, the beads will just stick to the membrane. in order to remove an existing membrane, there's really two effective techniques. One is scraping and removing it with a jackhammer equipped with a scraping blade. Another is to use a scarifier. Scarifying is a more aggressive surface preparation. Scarifiers use spinning blades to chip away at the concrete surface. Like I said, we remove existing membranes that are incompatible with the newly specified membrane. We can also use scarifiers to abrade the surface of the concrete prior to installing a bonded overlay, or we can even use them to remove high points in the slab so that water will flow better across the deck and off the plazas. Angle grinders are really versatile tools depending on what type of blade we're using. Here, a grinder is equipped, pardon me, here the angle grinder is equipped with a grinding wheel, and they're reprofiling the surface of the concrete around the drain. A flap wheel is a series of sandpaper sheets and a disc. It's being used here to roughen an installed PMMA primer. And a grinding wheel can be used to remove rust from metal and to roughen the surface of the metal. One final step before we install the membrane is to blast the surface of the slab with some compressed air to remove dust. And then the deck is primed. We prime slabs to improve the adhesion between the membrane and the concrete. And believe it or not, priming is also intended to lock in whatever dust is still on the slab. All right, that's it for surface preparation. Most projects should include some sort of combination of those methods in order to improve adhesion of membrane to the deck. Once we've got the membrane in place, how can you tell if it's watertight? There's a couple of different ways. For years, we've flood tested waterproofing membranes to check their integrity. A flood test involves plugging the drains, covering the membrane with up to 2 inches of water, and leaving it in place for 24 to 48 hours. During this time, observers should be checking the space underneath the membrane for leaks. It's important before you start one of these tests to make sure the structure can support the weight of water. In the cases where the substrate is sloped, it may be necessary to install dams to minimize the amount of water that's on the surface of the slab. If the slope is particularly steep, conducting a flood test might not be practical. Electronic leak detection is an alternate to flood testing. Both high and low voltage electronic leak detection, which are shown here on the bottom of the screen, attempt to complete an electric circuit between the testing equipment and the concrete slab. For this to work, both the concrete and steel reinforcement need to be electrically conductive, while the waterproofing membrane, most of them are not. Therefore, the membrane acts as an electrical insulator, preventing electrical current from flowing. If the test equipment is positioned near a breach in the membrane, the circuit should be completed and the meter should emit an alarm. Electronic leak detection is probably more schedule friendly than flood testing, because if you find a breach in the membrane, you can patch it and retest it a lot quicker than you can locate a breach in a flooded area, patch it and reflood it and run the test again for 24 to 48 hours. All right. Back to common Plaza components, working our way up. The next layer on top of the waterproofing membrane is typically a protection course. We specify protection courses to protect waterproofing from construction traffic and from UV exposure. Possible materials include modified bitumen roofing sheets, which are usually about usually less than 1/8 of an inch thick and flexible. Another option is a rigid asphalt board, which are up to 1/4 inch thick, and they provide more protection. And then we can get even more protection if we specify a 2 to 3 inch thick concrete protection slab. It's best practice to install the protection layer as soon as possible after the waterproofing is complete to protect it from the rest of the construction going on. However, it's got to be coordinated with any flood testing or electronic scanning of the membrane. Root barriers. If we've got planters on the plaza, the next layer of the assembly above the protection layer should be a root barrier. We specify them to keep roots from growing through the waterproofing membranes. The root barrier we see most often is an HDPE sheet, which is a thin, flexible plastic sheet. It's best to loose lay them with either wide laps at the seams or to tape the seams, and they should be installed directly on top of the waterproofing protection layer. Again, a 2 or 3 inch concrete topping slab in a planter offers more protection. The issue with protection layers and root barriers is we've got to decide between access and durability. Sheet goods and boards are relatively easy to remove in the event that repairs are necessary, but they don't provide the same level of protection as a concrete slab. On the other hand, the concrete slab is more expensive to remove and replace in the future if there is a repair necessary. All right, working our way up. The next layer in the assembly is typically a drainage course. This helps us ensure that water flows across the membrane to the drains or off the plaza. It's especially important in split slab construction where multiple layers of material can compress against the membrane surface and tend to obstruct the flow of water. Gravel is often used as a drainage course in planters. It's important that it be gap-sized gravel, so all the gravel should be roughly the same size so that there's spaces between the gravel for water to flow. Drainage composites, you're going to hear me call them drainage mats several times this afternoon, no doubt. These are plastic cores laminated to a geotextile fabric. The permeability of the fabric can vary, and the flow rate of the core can vary. It's, again, best practice to try to lap the seams in drainage composites, but more importantly, wrap fabric or tape around any cut edges to prevent the core from getting obstructed. And another option, if your plaza includes thermal insulation, are rigid insulation boards with grooves cut in them. The board shown here in the photo is upside down. The groove should be placed on top of the protection layer or drainage, the groove should be placed on top of the protection layer so that water can flow around the perimeter of the board. Drainage courses do a lot of good things for us. They help reduce hydrostatic pressure on the waterproofing membrane. They provide a space for water to freeze and thaw inside the assembly and minimize heave on the wearing course. And by keeping the thermal insulation dry, they maintain its thermal efficiency. A couple of lessons learned from investigations of drainage courses. In the photo on the left, the assembly lacked a protection layer, and there was vehicular traffic over this plaza. So the core from the drainage mat was driven down into the waterproofing membrane and cut the membrane to ribbons. The photo on the right is from a plaza that had a really thick wearing course. It was 12 to 15 inches deep. There was a protection layer in this instance. Again, the core from the drainage mat was driven down into the protection layer. It left an imprint on the protection layer, but it didn't damage the waterproofing membrane. Thermal insulation options, the product that we see most often is extruded polystyrene insulation or XPS board. And that's because it maintains its thermal insulating property even in a wet environment. It's got good compressive strength and minimal deformation. So the 10% deformation listed there on the slide means in a slab with a 2-inch thick board, you might expect 1/4 of an inch or less of compression of the board. And now that we're at the top, I'm going to turn it back over to Paul to talk to you about wearing course options.
All right, thank you, Jason. So probably the first and easiest wearing course to install is the concrete topping slab or wearing course. One thing you want to be careful about is I think good practice is to do a mock-up first, is especially with architectural concrete because of the changes in materials that we're all encountering lately with concrete, is you want to make sure the color you want is the color you get. And you need to work with the ready mix supplier to make sure your cement source is constant. If the color component is important to the aesthetic of what you're doing. And just so you can see is on the schematic we have here, we do have a overlay on many of them and a drainage layer that Jason talked about previously. And we're not, that they can be used, they cannot be used. It's really up to the design team. But we just showed that consistently throughout. But I just want to make sure you understand that's really a design component. And so you need to decide what you want to do. Here's installation of a drainage mat. On this one, the contractor is placing it on welded wire fabric on top and then putting the joints in as they go. So really, it's very consistent with normal concrete practice. Next is a pedestal system. This imposes some other challenges that are out there, and one of them is the installation becomes a little bit more difficult, but also the maintenance becomes a little bit more difficult because usually this system will adapt or percolate or settle over time. So usually it requires a little bit of maintenance to make sure it's shimmed properly, it's resting properly, so you don't get differences in elevation. They do offer certainly more flow below, but also it offers a spot for debris to reside. And sometimes with the drains, a lot will collect around the drains, and that needs to be maintained also. With the pedestal status, this is the installation, laying out the paver locations, and then placing the pedestals, installing the pedestals, and then you can see the completed system. Once again, these can be installed in basically a flat horizontal condition where the water passes through, but they always usually need a little bit of adjustment from time to time. Another system is the sand set paver system. This can be stone or clay. Oftentimes is what's called a pressed concrete, or unit pavers, let's call them. It's set on a sand setting bed, and you can see the contractors setting up for the installation and putting down their band, which they use as a layout point to build their system off of. And usually that requires some type of compaction of the setting material. So it's screeded and compacted, and then the pavers are installed. And on the lower right, you can see a running bond system that correlates. The new system's on the right, and the existing pavers are on the left. Another system, which is more the elegant system, is the granite paving system or other stone. And this is a mortar set system, and in this case, a thick set mortar system. These traditionally run about 2 inches. Often they're reinforced with a welded wire fabric. And how they're installed is usually you have to be careful about mixing your materials because it's important for these systems to be bonded and stable. You want to start setting the materials or putting your material, or setting materials in the area where your paver is going to go. Oftentimes, you want to bond coat the back of the stone and then set the paver. And usually it's proud or outboard of where you want it to settle, and then pound it into place by either a rubber or leather mallet, and then installing joint grout upon completion. And sometimes this could be fully grouted, it can be partially grouted with sealant, or in some cases be just compressible filler and sealant. And that's more of a design issue. Then you get to the bituminous setting beds. You'll see these oftentimes under unit pavers or clay pavers again, and that'll be a brick paver on an asphalt base. Sometimes there'll be a coarse gravel subbase. It really depends on what you're trying to achieve. On this particular system, you can see the concrete paving system is being established and laid out. On the next upper left side, you'll see setting the grade and somewhat screening it off and compressing the system. A tack coat can be installed, And then the pavers are being installed in a herringbone system, which is more common because of more places of contact by the stone. That'll be used in a heavier trafficked area. And then in the lower right is the system after it's been installed, and the joints are being sanded with this particular system. Jason?
Okay, thanks, Paul. I'm going to talk a little bit about drainage and how water moves both at the wearing course level and down at the membrane level. Like Paul said, with pedestal set systems, they're an example of an open joint wearing course where water quickly flows through the wearing course down to the membrane level. The surface of the structural slab should be sloped at 2%, which is approximately 1/4 of an inch per foot. It's both code required and good practice. The reason being, with construction tolerance and deflection of the slab, if we specify 2% and we get 1% slope, the water will still move toward the drain. The concrete topping slab and the mortar set pavers that Paul discussed are examples of closed joint systems. In these systems, most of the water flows on the surface of the wearing course toward the drains. A small amount seeps through the wearing course and reaches the membrane level. And over time, as the joints in the wearing course break down, more and more water is going to reach the membrane level. A closed joint system relies on something that we call a dual tier drain. And that's a drain with openings at the wearing course and at the membrane level that's intended to receive water at both levels. These are a couple lessons learned from plazas that had inadequate drainage. And what happened here is that water ponded or stagnated on top of the membrane. And as the minerals that the water picked up mixed with air, they formed hard deposits that could either clog the drainage mat, the drain body, or the drain pipe. And for a while, the owners were able to keep up with pressure washing the drains and the drain pipes. But eventually the deposits became too strong and built up too quickly. They blocked the flow of water out of the drainage mat and in the drain pipes. And this is just a diagram of a dual tier drain. Again, it's intended to accept water both at the surface of the slab and at the membrane level. It's important to protect the weeps or the opening at the membrane level from concrete or mortar setting beds. We want to make sure that they stay clear during construction. So we either place gravel around them or we wrap them in filter fabric. One quick lesson that we've learned the hard way, the more layers of filter fabric you wrap around the drain, the slower the water will flow into the drain. Be mindful of that. With trench drains, the type that we see most often are these manufactured drains in the image on top, which have plastic channels that are supported by metal grates. And my concern with this type of drain is that they don't have an opening to accept water at the membrane level. A workaround for that is to field fabricate your own trench drain. The diagram at the bottom shows a typical roof drain installed at the membrane level, and then a grate installed at the wearing course that's supported above the drain. A move that we see more and more lately is pre-treating walls and curbs, or installing the waterproofing membrane underneath a wall or curb before the field of the plaza is installed. I like this move because it results in a continuous waterproofing membrane across the surface of the structure, which both helps protect from leaks to the interior and helps protect the integrity of the structure. There's a couple of tricks if you're going to do this. One, any sort of reinforcing dowel in the curb or wall needs to be flashed to make sure that it stays watertight. And if your intent is to run the drainage mat underneath the wall or curb and send water underneath it, we've got to be sure that we keep that drainage mat clear during construction. We also have to be sure that the formwork for the walls or curbs is not nailed through this waterproofing. One thing that we found that helps is, because accidents do happen, the drainage mats do get clogged, is to drop a 2x4 into the formwork to create a bit of a mouse hole on top of the drainage mat. It's just a second avenue for water to flow under the curbs or walls. My personal opinion, it's low risk to drain water from the plaza into the planter. I'd rather we didn't drain water from the planter out into the plaza. I think doing so risks bringing soil and other debris with the water that could wind up obstructing the drainage course in the plaza. And then expansion joints. There's a lot I could say here, but in the interest of time, I will tell you this. Paul and I have lots of conversations about redundancy of expansion joints and secondary seals. And I think it's always a trade-off between performance, durability, and access and ability to repair these in service. The diagram on the right is from an expansion joint that we had to troubleshoot and figure out the cause of a water leak. And you can see there's multiple water seals. There's a backer rod and sealant at the structural slab level that the contractor installed to keep the building watertight during construction. No problem with that. I think that's a great idea. There's a neoprene gutter underneath the slab that the owner had installed prior to the repairs to capture water that was coming through the joint. That got left in place. So what we wound up with is a lot of avenues for water to migrate laterally. And by that, I mean, in and out of the screen, which makes tracking the source of a water leak difficult. So I would advocate that if the space below an expansion joint isn't critical, it may be better to have less seals than more. In this case, maybe removing the neoprene gutter after the construction was complete, maybe removing the backer rod and sealant at the structural slab level would have made tracking and repairing that leak a lot easier for us. And with that, I'm going to turn it back over to Paul, who's going to lead us on a quick case study of a plaza renovation.
Yeah, we've given you quite a bit of information. I just want to lead you through something that pulls it all together, at least a little bit. So it gives you a frame of reference with regards to what we're recommending. This is a plaza from the 60s. It's fairly tired over years of performance. Leaks had started to build up. It's not historic. It's not, there's nothing special about it. It's just a concrete wearing course with planters and other things, a pool deck, and many other amenities. A landscape architect laid out something to beautify it, update it. We're not going to talk much about that, but we're going to talk about the process of the plaza construction. The first thing is on this one, the membrane had been well past its service life. Flashings were failing. There was many other things going wrong. So the idea was remove and replace. Many things stayed similar. Some things were updated. Obviously, the waterproofing was done and concrete repair was done. There's been several questions on that. I'll just give a couple things: is doing the demolition work, surface preparation that you can see in both these slides, which are typical of normal concrete repair construction that are covered in a different webinar. But needless to say, heavy surface preparation, serving good practice in order to conduct the repairs. Then laying out the new concrete. Once that's done, is remove all the remnants of the repair of the remove all the remnants of the previous waterproofing, and then surface preparation, like Jason explained, with the shot blasting, and then using that curb technique that he just talked about, pre-treating around where the curbs are, placing the curbs above it, and this is for the planter. And then in this particular case, they're doing a hot applied system. It was being flashed, and then on the right, it was waterproofed. In today's world, this would probably be low voltage tested. One thing we encourage with all this, because many of the top surfaces are aesthetic, is to do mock-ups of the repair techniques. Once again, to verify what you're getting and to also verify the ability of the craftsman performing the work. And then finally, laying out the concrete, curing it, as Jason described. and then installing things back in the planters. On the left is the drainage system, which is specific to landscaped areas, and then putting in the fill materials. This was designed by a landscape architect, and then putting the plants back in. And of course, this is what people see. So at the very end, this is the most important sometimes, is how it looks. So in conclusion, what we did want to do is we gave you quite a bit of information, but one thing we'd like you to remember are some of these more important items that we put together. Is plaza construction and plaza renovation is challenging. It requires many different design areas of construction and contractor parts of construction. Experience in plaza work is really important. You have to use investigation openings to at least get a snapshot of what you're looking at, and you have to make judgments based on that. And what does that mean? You should really expect unforeseen conditions to pop up along the way, and be prepared to modify things in a short basis on how you move forward. You really want to front load your design and decisions as much as possible. Of all the things I think that are important, I think in my view is the waterproofing and drainage are really the key to success. A plaza can look fantastic, but if it leaks, it's a problem. Samples and mock-ups, like I just described, you really want to establish standards of the work as you move along, and then the importance of quality control and making sure what's installed has been tested going in, tested to make sure it's watertight, the expansion joints work. You really want to make sure everything works before it's covered up. Thank you.
All right, thank you, Paul, and thank you, Jason. That was a great presentation. All right, let's take our first question. What are your preferences for the waterproof coating? Hot applied, cold applied, rubberized, asphalt, something else?
I have been, my personal preference has been hot rubberized asphalt for years, but I realize that cold applied liquid membranes have their place. They're certainly safer to install, maybe even easier to install. So my personal preference is for an adhered membrane, either cold liquid or hot liquid applied.
Okay, next question. Should historic plazas be assumed to be fully sacrificial with no historic fabric that can sustain life cycle maintenance replacement?
Okay, I'll take that. That's a very complicated question, but I'll give you I guess a short answer is I think with the plaza, certainly you want to take care of the leakage. And I agree, you want to save as much historic fabric as you possibly can. One way to look at it is you probably want to go more towards the selective repair. In other words, what we've done on some plazas is we'll be a little bit surgical with the repair. In other words, most of the problems with the plazing could often occur if you're not looking at the original material on top. In other words, it's just primarily a leakage issue, is to attack the flashings, the drains, plumbing that comes through for water. In other words, try and get the areas where flashings are or expansion joints, and that allows you to be a little bit selective and try and retain as much original historic fabric as possible.
Okay, would a corrugated metal deck that is vented with slits suffice for allowing drying of the concrete? Can you expand on vented versus non-vented decks?
I think the answer to that is no. My understanding is that the vented deck is intended to let the excess water from placement of the concrete sort of bleed through, but it doesn't promote drying of the concrete. And I think that the Steel Deck Institute issued a position paper that says that.
Also, many of the manufacturers are, not many, some of the manufacturers are very cautious about warranting the application of a membrane to a concrete on a metal deck. And I think just like Jason mentioned in his portion, oftentimes it can be a lightweight on a metal deck, which even introduces even more moisture. And once again, a lot of warranties are not valid for that type of installation.
All right, our next question. When waterproofing a planter, some assemblies call for a drainage course below the protection layer. In the case of a mud slab, should the drainage course flash above the mud slab after it is poured?
Do you want me to take that, Jason?
Sure, Paul.
I don't know the answer. And what it is it's there's in our landscape architects we've worked with, they've done it both ways. And in some cases, there's drainage for the membrane and drainage for the plant materials. So really, that falls into the landscape designer's jurisdiction because it has to do with root health and the ability of moisture and water to either be present or pass through. But that becomes more of a plant design, whether it's trees, whether it's plants. We have seen filter fabrics in the past even that actually held water because the clay material and some of the soil that was used clogged the filter fabrics. And so I'd hate to give a broad brush answer to that. It's really something that should be talked about with the landscape architect on how to really tune that into your environment.
Okay. Could you put a pipe under the curb wall instead of a 2x4?
Oh, absolutely you could. Yeah, no problem with doing that. The one thing that I would avoid is a condition where either the pipe remains in place or you pull the pipe and you have a half round wall that you are in any way, shape, or form trying to flash with the waterproofing. If for some reason you need to do that, if you need to flash the mouse hole, I would encourage you to make it rectangular and as large as possible so that the workers have access to the sidewalls. But yes, you can absolutely put a pipe in a formwork to create a mouse hole underneath a wall or a curb.
Okay. How do you handle waterproofing the embeds, particularly threaded bolts that need to go into the structural deck? The waterproofing MFR often has issues with waterproofing threads.
Yeah, I don't have good news for you there. That we try to work out with our manufacturers, that we specify ahead of time and let them know if we're going to need to install threaded rod. I understand that they're not covered by a lot of warranties. We've had decent success flashing them with liquid applied membranes. But we've also worked on a number of projects where, I worked at a Plaza a couple of years ago where a plumbing contractor came through and supported a bunch of pipe on threaded rod. And we had to go through and take out about 400 threaded rod that penetrated the waterproofing membrane. Because for some waterproofing materials, there's just not a good way to get threaded rod watertight. And you need to try to use a smooth shank anchor or rod if you can. Sorry, I don't have a better answer for that one.
All right, let's try this one. What's the advantage of mortar set over sand set paving?
Yeah, I can take that. Sometimes that's driven by the material you're using. Like say if it's a unit paver, you'd probably want to go with sand set or bituminous. However, with the thicker materials, such as granite or bigger materials, sand can be used, but sometimes that can be washed away or the fines can drift away through power washing, through natural water flow and things like that. My preference happens to be mortar set systems. However, if you're using a mortar set system, there's very little criteria on how it's made, mixed, and other things like that. So I think you really want to go with a mock-up on the installation of it. And you have lots of typical issues with installation that you have to watch for. but often, many times we've seen where not enough liquid could be used. Whereas you want to make sure, just like Jason had mentioned before, is keep your eye on the quality assurance and control to make sure things are being mixed properly. One thing I like to do is with the mortar manufacturers is make sure they're on site. You review the mixing methods and actually the ingredients that are used and make sure it's done correctly, because sometimes there's debate between the installer and the mixer on what's the appropriate amount of moisture. But those are my tips with regards to mortar mixing.
Okay, we've got time for one more question. How many years should a planned replacement cycle be for Plaza systems for capital planning by owners? I'm afraid it's short, like 30 years.
I have a quick answer for that. Is systems I've seen where the waterproofing fails right away or may not be the best system, those can be pretty quick. And then there's some systems that we've seen down 40, 50 years where there's no leaks and the top surface gives out. And I think the lesson to be learned is I think waterproofing is still the key in my eyes, as far as if you want to put effort into something to make sure it's right, is the waterproofing. Because if that fails, your service life goes way down, because even if your surface is perfect, if it's leaking, you're going to have to do some deconstruction. So that's the easiest way, in my view, to extend the service life, is pay attention to what Jason said. But also, I think then you're just stuck with the durability that's what's on top. Granite systems, they really tend to last a long time. Granite is such a durable material, but of course in life it's the most expensive in my eyes.
Okay. Thank you, Paul, and thank you, Jason, and thank you all for joining us. You submitted a lot of great questions. We did not have time to get to all of them today, but Jason and/or Paul will follow up with you afterwards. Please keep an eye out for an email from us this afternoon with links to watch the recording of the webinar and download a PDF copy of the slides, as well as your certificate of completion. And then finally, before you log off today, there's a pink icon at the bottom of your screen that opens a very brief survey about today's webinar, including a topic to suggest future WJE webinars. All feedback is welcome. We'd really appreciate it if you take 1 minute to fill that out. If you have any questions, please don't hesitate to reach out to Paul or Jason about their presentation, the topics covered today. And if you have any questions about WJE webinars, please reach out to us at webinars@wje.com. So again, thank you so much for your time, and we hope you have a great rest of the day.